Hi students, welcome to my first training session on on-off level control. So the name itself give you some indication that either the valve which is going to be completely on or it will be completely off. There is no intermediate positions. That means, let us say, if you wanted to control the level in the tank, and either I have to go for completely open the valve. It does the job of completely open the valve and completely close the valve. There will be no intermediate positions in between. And these kind of control systems are called on-off control systems, and these are very economical systems because you cannot precisely control the processes using these controls. And let us say for maintaining the level in the tank, so expensive controllers are not required. In such cases, this kind of controllers are used. But in case of exothermic reactions in a reactor that is taking place where the precise valve operation is necessary, then we go for the PI, PID, cascade, feed forward. These kind of a bit traditional advanced control systems we have to use. And let me show you the simulating platform. This is how the DCS framework looks like, and you are going to see the processes on this graphic window. And from this graphic window we have to learn many things. One is, you can see a feed that is coming into the tank or vessel and feed that is going out from the vessel. The inlet flow to the tank or vessel is controlled by this on-off shut-off valve. The outlet flow is controlled by HIC. HIC indicates the hand indicating control or human indicating control, you can say. That means you have to operate this valve manually inside the plant. There is no control process that is here for this valve. Whereas this valve is controlled by controller, which is called on-off level control systems. On-off level controls has two set points. One is high set point, second is low set point. What is this high set point? Means, assume I should not go beyond 80% of the tank level. That is the high set point. What is the low set point? I should not go the minimum 40% level inside the tank. That is a low set point. So based on this high set and low set, the controller operation is going to take place. And before we go to the controllers, let us see what different indicators on the screen. This is the feed that is going into the tank with a flow rate of 50 kg per hour, and the feed that is going out of the tank, which is also 50 kg per hour. That means the tank is under steady state condition. Okay, the amount which is coming in, same amount is going out. Just a second. Yeah. And this is the valve that is connected to this control, which is on-off controls. The moment I click the controller, I have some indicators on this place. You can see process value, set point value, and manipulated variable. What is the process value? Presently the tank level is around 50.17%. That is called, what is the present value or level of the tank is called the process value. Set value, that means this is high set value. That means what is the maximum tank level can go, that is the high set. Here it is given 80%. That means the tank level should not increase more than 80%. That is called the high set point. And what is the manipulated variable? The manipulated variable is something indicating the valve position. Here you can see the valve position. Now 100% means 100% open, because then only the flow can come in. Right now presently 50 kg per hour flow is going into the vessel and 50 kg per hour going out from the vessel. So now to have this thing in steady state, the valve has to be open. And because the present value is 50%, the valve is completely open. What happens? Let us assume hand indicating control. I can able to change the hand. Let us say before I go to the hand indicating control, let us see the low set point. Here the present process value is 50, that means present level of the tank. Set value, which is 40%. That means the low set point. That means the tank level should not go below the 40% level. That is what the set value for the low set point. What is the present value condition? Now the valve is open completely. So that is why it's 100%. Only thing we have to note here is the high set value for the controller is 80 and low set value for the controller is 40. And let us see what happens. Because now hand indicating control, that means you have to operate this valve manually inside the plant if this thing exists in the process plant. Now present 50% valve opening is there. So if you click, the moment you click here, it is showing the manipulated variable is 50%. That means the valve is now 50% open. And the moment you can change this valve conditions, see what happens. What happens if I slightly close my valve? That means I am trying to reduce the outlet flow. If I am trying to reduce the outlet flow, what happens? Because the inflow is 50, outflow is less than 50, the tank level starts to raise. What happens? Once the tank level hits the high set point, which is 80, the valve will shut off. And slowly the level will go down because there is valve now presently it is shut off. And after this shut off, the flow into the vessel is reduced, then the level of the tank will be reduced. Once it touches the low set point, which is 40, the valve will again open. This is what we are going to see now. Let us see what happens. Let me now, I'll make 50% open now, hand indicating control HIC. Now I'll make it 30. See the tank level here. The tank level, see the process value here. Earlier it was 50.16, now 51, 52. You can see process value now the tank level is rising because I have lowered down the outflow. Now outflow you can see less than 50. That means of course we are incoming is 50, the outlet is 30, definitely the level in the tank is going to rise. That is where the process value is increasing here. That means the level in the tank is increasing here. And because see the moment this process value hits 80, this valve will be closed. That's we are going to see very sooner. And let me, because it slowly it is increasing, let me increase the time a bit. I will take it much faster. I have things in my control now. It is pleasant, things are happening, dynamics are happening at a present time. So what if I increase the 10 times faster? What happens? That means fast forwarding the things a bit. And let us see here. The tank is rising now, 68, 69, 71, 72, 73, 74, 75. See the process value, 78. It hits 80. So once it hit it, the valve was shut off. What happens to process value now? 57, 55, 52. Now the moment it hits 40, again the valve will be open. See, moment it hits, the valve will be open. This is how the operation of a on-off level control. And this is called graphic window. Normally in industry is called distributed control systems window. And in graphic window you can able to see the things, what is happening, present what is the level of the tank, because we cannot see what is happening in the tank inside. Instead we have the sensor that will measure the level and send a signal to the controller. The controller will take the action according to the set value we have given. This is the one controller I can say. Here we can't able to change. Precise control is not possible with this on-off control system. That is why we go for P controllers, PI controller. That means different. If you have to maintain the 50%, it will try to maintain that 50. There is no upper bound and lower bound. Here you have upper bound 80 and lower bound is 40. So let us see the trend window. In trend window, actually you can see the trend. Here this line is indicating. Here I can able to see. What are the trends I wanted to see? Actually I can select and I can put on the screen so that I wanted to see three things: higher set point, lower set point and a present value. You can see this is how the trend looks like. The top line is the higher set point, which is 80, and this color indicating lower set point, which is 40. High set, and what is the present? This is the present value. The present value is fluctuating between high set and low set, because the moment we close the valve at the outlet, what is happening? Slowly the tank level is rising. The moment it tries to reach 80, that means it has reached the high set point. Suddenly the valve will be closed. The moment the valve will be closed, there is no more inflow into the system. Automatically the level in the tank will reduce. And the moment it tries to touch the 40 line, again the valve will be open. So automatically again the valve 40, again valve will be open, and you can able to see all sorts of ups and downs in this process value, present value, high set, low set, and the present value. This is how you can able to see the things and on a trend window. This is the beauty of the software, to see the things, and you can play the things in many different ways. Example, if I have this set point, now I can change this high set and low set. See, now it is between 80 and 40. I can now change from 60 and 30. High set is 60 now, and low set point is 30 now. Now what happens? Let us see in the trend window what is happening. Okay, in trend window, right, if you now see the high set point is now set points are updated. Now the high set point is 60, and low set point is 30. My present process value, now it fluctuates between 60 and 30. This is how the set point is going to affect it. And in hope, this is the kind of a different slow controllers we can say. And after this, and this is the graphic window. And the first lecture is very important, because you need to see what are the indicators. C indicating controllers. FI means flow indicator. HIC means hand indicator. That means there is no control action there. You have to manually open and close the valve. Next time we will meet up with a different module. Now we have seen the on-off level control systems. Maybe next time we will discuss about the temperature control. That is, if I have to maintain the certain temperature, high set, low set temperatures, how the things will go, we are going to see. And thank you, and be subscribed for having to update and more about this particular plant operator training using simulated modules. And thank you very much. See you later.